So here we have a vector valued function r. We take its cross product with the second derivative of r with respect to a scalar parameter t. So if we take the integration of that particular vector function with respect to t, then this is going to give us the vector function r crossed with its first derivative with respect to t plus some arbitrary constant c. So let's try to show that. So what we'll do, we will start with r vector crossed with its first derivative with respect to t, and then we will take its derivative with respect to t. For that, we will consider r vector to be the first function. The first function in the sense is the first vector valued function, and this is a second vector valued function. Now using the definition of the product rule, so we will take derivative with respect to t of our first function, so that's r vector, and then we will cross it with our second function, which is dr vector over dt, plus we will take the first function, which is r vector, and cross it with the derivative with respect to t of our second function, which is dr over dt. Now, as per definition of the cross product, dr vector over dt, they are parallel to each other, so that means the cross product will go to 0. So now we are left with only the second term, which is r vector crossed with the derivative with respect to t of the first derivative of r. So this will become the second derivative of vector r with respect to t. So that means derivative with respect to t of the vector cross product between r with its first derivative with respect to t. So that's equivalent to r vector crossed with its second derivative of r with respect to t. Now we start from the left hand side. So here we have integration of vector r crossed with d squared r vector over dt squared. So we'll integrate it with respect to t. So that means we'll multiply with dt. So this must give us what? This is the same as, so instead of r vector crossed with its second derivative, so we'll replace it with d over dt of r vector crossed with dr vector over dt. So this is multiplied to dt. So when we integrate it, this is simply equals to r vector crossed with dr vector over dt. And whenever we perform an integration, this will leave us with a constant of integration, which is, let's call it c vector c. Now this constant is a vector because on the left hand side we are integrating a vector valued function, so the result must be a vector valued function which we are obtaining. That's r vector cross dr vector over dt, plus we need to add it to some another value, so this has to be a vector in order for the equation to make sense. So this c vector is now an arbitrary vector. So hence we have shown that when we take the integration of the vector cross product between r vector and the second derivative, then this is going to give us vector r crossed with the first derivative of r with respect to t plus the constant of integration c.